As we go through this, you'll see shaded lines that are transparent lines that are different colors. That's meaning that they go with some of the same concepts in different parts of this map. So first off, what is a function? And we should know this by now. You should have this definition memorized. A function is each member of the domain, x values, is paired with only one member of the range, or y values. There are a couple of different ways that we can represent functions, and the first way I want to talk about is, let me get that out of the way. Anyway, is verbal. So we have independent variables, which would be your x value. An example would be time. You have dependent variables, that's your y value. An example would be distance. A rate of change can be used as slope, rise over run, or your m value. And then the initial value could be y-intercept, your starting point, or your b value. Now, if you notice, all of your independent variables, they're going to have red arrows. Your dependent variables have orange, yellows, or arrows. Your rate of change has green, and your initial has like a teal kind of color. Now, how do these show up in equations? The first type of equation we talked about was slope-intercept form, which is y equals mx plus b. And the important thing about this is that when the y-intercept is negative, the b value is subtracted. And so it could be y equals negative mx minus b, or those positive and negatives change, but the template for that equation is the same. The second type of equation we looked at was standard form. This was ax plus by equals c. And remember, a must be a positive whole number, and there's no fractional or decimal numbers that are allowed. And you can solve an equation for y and get a slope-intercept form equation, or you can solve an equation for the constant and get a standard form equation, and we did lots of practice with that. And then how do we know if it's a linear function? Remember, the word line is in the word linear, so we're talking about a straight line. It is a linear function if the exponent of 1 is on the x variable. Now, remember, whenever you have an exponent of 1, we don't actually write 1. So if the x essentially doesn't have an exponent written on it, then it would be a linear function. If it does have an exponent like negative, something like -1, or something like -1 would be okay. Something like 2, 3, anything like that, you're starting to get into nonlinear functions. Okay, and then we have tables. So tables have two columns. They have an input and an output column. Notice the red arrow for independent variables is going to input, and the orange arrow for the dependent variables is going to output. Then we have our green arrows for rate of change. This is looking at how does the y value change compared to how the x value changes. And it's a multiplicative relationship, meaning we're looking at x times what gives us y. We're not looking at adding or subtracting things. We're looking at multiplication. Then we have initial values. So on the table, your initial value always shows up as x is equal to 0, and then y is any value that we need it to be. And how do we know if the relationship in the table is a function? It is a function if no x value repeats. However, y values may repeat. It is not a function if at least one x value repeats. And then we usually graph after we get to table or get our tables done. So on the graphs, we have an x-axis, which is our domain, and the y-axis, which is our range. Remember that our intervals are evenly spaced values, and we can describe the graphs using some characteristics, such as discrete versus continuous. And there's a red arrow going from that because you determine if it is discrete or continuous based on your x value or your independent variable. Another way that we can describe graphs is increasing or decreasing, and that is determined by your rate of change or slope, and linear or nonlinear, and we've already talked about how to determine that. Your initial values show up as 0 something, which is your y value, and then how do we know if it's a function? And it would have to pass the vertical line test. So this is what the entire mind map or brainstorming or web, whatever you really want to call it, looks like, and you can see that these show up in so many different ways. So what we want to do is, can we take a verbal situation and compare it to a table situation or an equation situation or a graph situation or a representation? That's kind of what we need to be able to do, is to move fluently between the 4 representations and know at every point where is that initial value, at every point where is the rate of change, and so on.